Alright, ladies and gentlemen, in this video we are going to open up our discussion on algebraic reasoning. Now the goal just in general when we're talking about algebraic reasoning is to think about all of our linear equations, or even technically some of our quadratic equations that we've solved for in algebra, and have a reason for every step that we make. Sometimes we get into this kind of habit where we just kind of follow what our teachers are doing. They tell us to distribute, and then they tell us to subtract, and then so on and so forth. But we don't always remember or realize why we are doing what we are doing when we are solving for a missing variable in algebra. And so that's what algebraic reasoning is all about. In geometry, we have the opportunity to not only solve for algebraic problems, but we also get an opportunity to really figure out why we are doing what we are doing. So in this video, we are going to identify some of the basic algebraic properties, and these are going to be things that we have talked about in the past. And then we're going to solve some algebraic problems using actual appropriate reasoning for each and every step we take. So let's start off with an example here in which we have all of our steps onto the left-hand side. And what we're going to focus on is just basically saying this is the algebra that we've done on the left-hand side. And I want to go ahead and just fill in the blanks of our justification as we kind of go on. And so we'll kind of see what's to the left and then kind of figure out what comes next in terms of getting ready for our algebraic reasoning. So the very first thing that you see is the given equation. So let's keep that in mind first and foremost. You should always be starting with what is given. So your very first line in an algebraic reasoning problem should be the original problem, and your justification is just simply going to be given. Okay, so your justification is just going to be given. So what about what's left? So let's see what happened here. From the first step down to the second step, it looks like we multiplied 2 times x and 2 times 3. Well, 2 times x and 2 times 3 with those set of parentheses, that is our use of the distributive property, our distributive property. All right, and so then as we kind of continue going on, what do we notice? We notice that 6 minus 5 actually became 1. And so what do we really call that? Well, really, when we combine like terms, it's tempting to call it combined like terms, and technically you're not wrong, but a little bit more mathematically makes a little more sense. We're just going to call it simplify. So that is called simplify, right? And then as we continue to go on, as we're solving for x, remember we want to get both x, or all the x's on one side of the equal sign. And so if we see what's going on here, what's in red are these operations. So they're physically doing the operation right here of subtracting. They're subtracting 2x on the left, and they're subtracting 2x on the right. So that is called our subtraction property of equality. Property of equality. And then here, once again, it looks like they went ahead and just combined some like terms, and they simplified as they went down. And so then once again here, what's in red is our operation. So they physically subtracted 4 across the equal sign. So there we go again. There is our subtraction property of equality. Equality because we're using an equal sign, right? And then once we actually subtracted those numbers, we simplified. And then what's in red here, once again, we see what we did. We physically just divided both sides by 3 to get x by itself. And so that is our division property of equality. And then last but not least, we simplified. And then we wanted to go ahead and make sure that we read from left to right x equals. Now this isn't the most important part of it. Let's see if we kind of remember. Do we remember what it is when we kind of flip over what's going on the left and the right side of that equal sign? If not, that is called your symmetric property of equality. Symmetric property of equality. And so that's our first kind of algebraic reasoning. Now, most of the time we are going to be doing these completely from scratch. And these are going to be some of our big core concepts and our properties from algebra that we're going to have to make sure that we know. All of our additions, subtraction, multiplication, and division. We have our substitution property of equality, which means that we're going to swap out any values that are equal to each other. And then, of course, we also know our distributive property of equality as well. So let's take a look at one more example and kind of an open-ended question. And let me kind of think about this. And I challenge you to kind of stop the video after I ask this, but really, how can algebraic properties help you solve an equation? Like, really, try to stop the video and see if you can kind of think why. Well, when we think about these properties, it's physically guiding us along the way to make sure that we are appropriately doing the operations. We are physically knowing why we are doing what we are doing. It's not just because we saw our teachers back in middle school just constantly going over and over and over again, and you're memorizing how the steps went, but it's we physically know why we are doing what we are doing. Let's take a look at one here from scratch. So once again, our goal here is to start with what is given. So we're going to start with what is given, and then we will go ahead, and like I said on the right-hand side, it's just going to be given. So what's the first thing we would do here? Well, looks like I would distribute on both sides, or to both terms, excuse me. So we have 3x plus 3 minus 1 equals negative 13. So I distributed our distributive property. I want to go ahead and combine these like terms, so I get 3x plus 2 equals negative 13. And that's going to be a simplify. And so now it's just, we kind of know what to do from here. We want to subtract 2 from both sides. And so if I subtract 2 from both sides, I get negative 15. And so there's our subtraction property of equality. And then last but not least, we would divide both sides by 3. And that is our division property of equality. And then we'll just finish up, and x equals negative 5 by simplifying. Okay? All right, so as we kind of look through these, the goal is to try to not to skip as many steps, try to really make sure that we aren't combining a bunch of steps all into one. And I know sometimes students are kind of like, well, why do we have to do this? We already know how to solve these algebraic problems. But it does truly help us understand why we are doing what we are doing.